Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
This is SpaceTime, Series 24, Episode 73, full broadcast on the 28th of June 2021. Coming up on SpaceTime, the Hubble Space Telescope drops into safe mode following a major onboard computer crash. Southern Launch gets approval for its South Australian orbital launch complex. And a strange new object from the Oort Cloud on its way into our solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Hubble Space Telescope has dropped into safe mode following a key onboard computer crash. All cameras and scientific instruments are now offline, and astronomical programs have been halted as mission managers at NASA's Goddard Space Flight Center in Greenbelt, Maryland, try to determine what's gone wrong and rectify the problem. Mission managers originally thought that a bad memory board in one of the orbiting observatory's 1980s vintage computers, which controlled the science instruments, may have caused the shutdown. Flight controllers tried to restart that computer, but it crashed again. After performing tests on several of the computer's memory modules, the results indicate that a different piece of computer hardware must have caused the problem, with the memory errors simply being a symptom. Technicians are now planning to switch to a backup memory unit. The operations team's investigating whether what's known as standard interface hardware, which bridges the communications between the computer's central processing module and other components, or the central processing module itself, is responsible for the issue. If the problem with the computer can't be fixed, the operations team will switch to a backup payload computer. The team's already conducted ground test and operations procedure reviews needed to verify all the commanding requirements needed to perform the switch on the spacecraft. If the backup payload computer's hardware is turned on, several days will be required to assess the computer's performance and restore normal science operations. However, the backup computer's not been powered on since its installation in 2009. Imagine the hours of updates it'd be after if it was your laptop. NASA says the computer was thoroughly tested on the ground prior to its installation on the spacecraft. The payload computer is a NASA standard spacecraft Computer 1 system built in the 1980s that's located on the Science Instrument Command and Data Handling Unit. After 18 years in orbit, the original Science Instrument Command and Data Handling Unit experienced a failure in 2008. That delayed the final servicing mission to Hubble while a replacement was prepared for flight. In May 2009, STS-125 was launched and the astronauts installed the existing unit as the backup. The replacement contains the original hardware from the 1980s, complete with 4 independent 64K memory modules of complementary metal oxide semiconductor memory. Only one memory module is used operationally, with the other 3 serving as backups. All 4 modules can be used and accessed from either of the redundant payload computers. Launched in 1990 with more than 30 years of operations now behind it, the Hubble Space Telescope's made observations which have captured the world's imagination and deepened science's understanding of the cosmos. This is SpaceTime. Still to come, Southern Launch gets approval for its new South Australian orbital launch complex, and a mysterious new Oort Cloud object on its way into our solar system. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Southern Launch's new Whalers Way orbital launch complex is a step closer to fruition, with formal approval now given for construction to begin. The initial approval will see the construction of a temporary launch pad and support facilities needed to conduct 3 test flights, designed to gather data to validate computational noise and vibration modelling for the site, which is located on South Australia's Eyre Peninsula near the fishing town of Port Lincoln. The contract calls for the test flight program to begin before the 31st of December. Southern Launch has spent the past 8 months working with government and independent agencies to put together their development proposal. The launch complex covers approximately 1,200 hectares of open land, including over 6 kilometres of ocean frontage for southward launch trajectories. The company says Whalers Way could eventually carry out 40 orbital launches a year. Rockets will fly south over the Great Southern Ocean into polar orbits. Korean space company Perigee Aerospace has already signed up to use the facility, with 8 launches now on its order books. Before the COVID-19 pandemic hit, the company had planned to launch its first rocket, Blue Whale 1, from the Whalers Way complex almost exactly a year ago. The 8.5-metre tall, 1,790-kilogram two-stage launch vehicle, backed by Samsung, is designed to deliver a 150-kilogram payload into a 500-kilometre high sun-synchronous orbit. Once Blue Whale 1's operational, Perigee plans to develop a larger rocket capable of carrying payloads of up to 300 kilograms into low Earth orbit. Southern Launch already operates a separate rocket test range on Aboriginal land at Coonimba, 40 kilometres from Ceduna on the South Australian west coast, which is used to trial launch vehicles. Meanwhile, a second company, Equatorial Launch Australia, plans to provide launch services for sounding rocket flights for NASA from the new purpose-built Arnhem Space Centre launch complex near Nhulunbuy, 700 kilometres southeast of the Northern Territory capital, Darwin. The suborbital flights will use Black Brant rockets to carry a series of scientific payloads, including spectrometers to study the light spectrums from the Alpha Centauri triple star system, looking for atmospheres around exoplanets, and to detect interstellar gas so as to better understand the structure and evolution of galaxies. And of course, last month, a third company, Gilmour Space Technologies, reached an agreement to develop its own launch complex at Abbott Point near Bowen in tropical North Queensland. They'll undertake orbital launches on equatorial trajectories using their new Ares rocket. Gilmour also plans to make use of the Whalers Way launch complex once it's built for Ares rockets on polar flights. This is SpaceTime. Still to come, a mysterious new Oort Cloud object on its way, and a new instrument to make one of the world's biggest telescopes even better. All that and more still to come on SpaceTime. Astronomers have discovered a large Oort Cloud object several hundred kilometres wide, which is heading for the inner solar system. Early estimates suggest the object, which has been named 2014 UN 271, is between 100 and 370 kilometres across, placing it somewhere between a really big comet and a really small dwarf planet. Either way, it makes it one of the largest known Oort Cloud objects ever observed. The Oort Cloud is a theoretical sphere of comets, frozen worlds and icy debris extending from around 300 billion kilometres out to over a light year from the Sun deep into interstellar space. The region contains objects which were either created early in the solar system's history or which originated from beyond our solar system and which have become gravitationally bound to the Sun. The cloud was first postulated in 1950 by the Dutch astronomer Jan Henrik Oort in order to explain why there continue to be new comets with elongated orbits in our solar system. The Oort Cloud is thought to be different from the Kuiper Belt, the ring of frozen worlds, comets and icy debris circling the Sun beyond the orbit of Neptune, thought to have been formed out of the builder's rubble left over from the formation of the solar system 4.6 billion years ago. 2014 UN-271 was discovered in archival images collected for the Dark Energy Survey between 2014 and 2018. Astronomers found it was on a 612,190-year orbit stretching from the Oort Cloud to the inner solar system, which is almost perpendicular to the ecliptic, the plane created by the planets as they orbit the Sun. It's currently on its inbound part of that journey, about 22 astronomical units out from the Sun, which is closer than the orbit of Neptune, an astronomical unit being the average distance between the Earth and the Sun, which equates to 150 million kilometres or 8.3 light minutes. In the past 7 years, 2014 UN-271 has travelled about 7 astronomical units. It'll make its closest approach to the Earth and the Sun in 2031, when after flying over the Sun it'll swing round near the orbit of Saturn at about 10.9 astronomical units before heading back out again. While too small to see with the unaided eye, 2014 UN-271 should appear as bright as Pluto in telescopes. It might even begin to resemble a comet with a coma and tail as its icy surface begins to evaporate. And it's worth pondering that the last time this particular object was this close to the Earth was at a time when the first Neanderthals may have started walking on the Earth's surface, and a time long before the first Homo sapiens existed. This is SpaceTime. Still to come, a new instrument to make one of the world's biggest telescopes even better. And later on the Science Report, Bruce Pascoe's controversial book Dark Emu, slammed by leading scientists. All that and more still to come on SpaceTime. Scientists are developing a new instrument for one of the world's biggest telescopes that will allow it to peer even further back in space and time. The instrument is called the Multi-Conjugate Adaptive Optics Assisted Visible Imager and Spectrograph, or MAVIS for short. It combines adaptive optics and spectroscopy while at the same time extending its range over more frequencies in the visible light regime. MAVIS will be fitted to one of the 4 8.2-metre telescopes that make up the European Southern Observatory's Very Large Telescope Array, or VLT, in Chile. Once fitted, it'll produce images 3 times sharper than those of the Hubble Space Telescope, allowing astronomers to see further and clearer, unlocking mysteries of the early universe. The $57 million 7-year project to build the instrument is being led by the Australian National University, with a consortium including Macquarie University. Put simply, MAVIS will remove the blurring from images caused by turbulence in Earth's atmosphere, in the process pushing back the cosmic frontier of what's visible. MAVIS project scientist Associate Professor Richard McDermott from Macquarie University says the ability to deliver corrected optical images over a wide field of view using one of the world's largest telescopes is what makes MAVIS a first-of-its-kind instrument. He says the new technology on MAVIS will allow astronomers to see further back in time than ever before, allowing them to explore how the first stars were formed more than 13 billion years ago, and even how weather changes on distant planets and moons.
MAVIS is an instrument that we are building that's going to be attached to a telescope in Chile. The special thing about this instrument is that it's going to allow that telescope to correct for the effects of Earth's atmosphere and give us a sharper view of the night skies than we've been able to obtain before. In fact, we're expecting it to be even sharper and clearer than the Hubble Space Telescope.
So this is adaptive optics we're talking about.
Right, yes. So MAVIS is actually an acronym, and it stands for a Multi-Conjugate Adaptive Optics Assisted Visible Imager and Spectrograph. That's a bit of a mouthful, but it shortens to MAVIS. And the first part of the acronym, the Multi-Conjugate Adaptive Optics, that's a relatively new way of doing what I said, correcting for Earth's atmosphere. And it's doing that through this technique of of adaptive optics, and it's doing it in a way that allows us to actually correct a larger field of view for the instrument. That's the multi-conjugate part we get to correct for actually different layers in Earth's atmosphere, and that allows us to deliver a very sharp and a very large field of view to this instrument.
Now, adaptive optics, as we know it today, doesn't enhance the entire visual spectrum, only a part of it, and this extends that to a larger area of the electromagnetic spectrum.
That's correct. So the technique of adaptive optics, and maybe I should explain what adaptive optics is. When we look out into space from the ground, we have to look through Earth's atmosphere. And of course, the atmosphere is a very dynamic entity, and there's turbulence, there's wind, and those effects change the path of the light that comes towards us, and it does that on very short timescales. Now, we can see that effect with the naked eye when we see stars twinkling. That twinkling effect is the effect of Earth's atmosphere, but when we look then with a large telescope, this shows up as a kind of a blurring of the image. And so that's what adaptive optics helps us to correct for and remove. Now, with MAVIS, we're pushing this technique to what we call the visible light spectrum, or it's the kind of light that our eyes are sensitive to. So existing adaptive optics has typically been done at longer wavelengths, so infrared wavelengths, and it's a bit easier to make these corrections at those wavelengths for various reasons. But basically, the effect is it varies less quickly, and the optics that we have to use at longer wavelengths can be larger and easier to make. But with MAVIS, we're trying to push this to shorter wavelengths into the visible regime, and we're doing that for a number of reasons. The most obvious one is that the visible light spectrum has a lot of information in it, a lot of rich chemical and dynamical information that we can get for astrophysical objects. It's a very information-rich regime, but it's very hard to work in with this adaptive optics because the timescales are very short, and the manufacture of the optics that we have to make is very challenging. But we're confident that we can do this with MAVIS, and that's one of the new areas that this instrument is going to push into from a technology standpoint.
So it works by shining a laser up into the sky, and it hits sodium atoms at a reasonably high altitude where any distortion is picked up by a computer. That affects actuators on the mirror itself.
That's pretty correct, yes. As I said, with adaptive optics, we're basically measuring what the atmosphere is doing, and we have to do that on very short timescales. So we have to measure 1,000 or 2,000 times per second. And so because we need to make those measurements, we need bright sources to look at, and those will give us the photons of light that let us make those measurements. But bright stars aren't everywhere in the sky, and so instead we shine bright lasers up, and they indeed stimulate a part of the atmosphere that's rich in sodium, and basically fluoresces or lights up and creates a point of light at around 100 kilometers above our heads. And we can look at that as a probe of what the atmosphere is doing. And so we measure what the atmosphere is doing with these so-called laser guide stars. And then we change the shape of a mirror. It's called a deformable mirror. There's actually 3 of them in MAVIS. We change the shape of the mirror, which basically does the reverse distortion to the light as what the atmosphere did. And once the light comes off of those mirrors, it is basically corrected for the distortions caused by Earth's atmosphere. So yeah, we have big lasers, we have these large so-called deformable mirrors, which are moving, at 1,000 times per second. We're measuring the atmosphere at the same rate. And all of that has to come together and work, and that will deliver these sort of beautiful corrected images that MAVIS is going to look at.
And that's the first part of MAVIS, but there's also the spectrographic side of it as well.
That's correct. So all we've talked about is the adaptive optics part. That's basically cleaning up the image and sharpening it up and correcting for Earth's atmosphere. But then we want to look at that light and we want to analyze it and make measurements, and that's where the science comes in. And so MAVIS is going to have an imager, so just taking kind of broad light images, but it also has what we call an integral field spectrograph. And that is kind of like an imager, but imagine an image where every pixel has a rainbow spectrum behind it. And so that breaks up the light into its constituent wavelengths, and that's where we get these chemical and dynamical fingerprints from the astrophysical sources that we're looking at.
And this equipment will be fitted to one of the 4 8-meter telescopes on the VLT.
That's correct. One of the reasons we're so proud and excited to be working on MAVIS is that it's actually an Australian-led project. And so it's an international consortium. We have partners in Italy and France that are helping us build MAVIS, but that group is led by teams here in Australia. And the reason that we're able to lead such an instrument for the European Southern Observatory is because in 2017, the Australian government started a 10-year partnership with the European Southern Observatory that brings in Australia almost like a full partner for that consortium. And that gives us access to the telescopes, so Australian researchers can use those telescopes, but it also lets us lead and develop technology for those telescopes. And that's a really exciting benefit to this partnership that we currently have with ESO. So yes, we'll be building the MAVIS between the groups here in Australia and in Italy. Then we bring it all together and we ship it to Chile, where it gets installed in the telescope there at the Paranal Observatory, and that's where it will live and work.
That's MAVIS project scientist Associate Professor Richard McDermott from Macquarie University. And this is Space Time.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study, which is yet to be peer-reviewed, suggests that people whose second shot is the Pfizer vaccine after a first shot of the AstraZeneca jab may develop better immune protection than those given 2 AstraZeneca doses. Now, it's important to point out that these are only preliminary results and they're from a very small study. But they do follow several other studies from the UK, Spain and Germany, which have produced similar positive preliminary findings on the immune response. However, scientists warn that all these studies are still far too small to provide a definitive recommendation. The findings come in the wake of Canada's decision to change its recommendation on mixing vaccines and now recommend that people who receive AstraZeneca as the first dose should get Pfizer or Moderna for their second shot. Australia recently announced that it was phasing out the AstraZeneca vaccine following TGA approval of Moderna and access to additional doses of the Pfizer vaccine. The World Health Organization now estimates more than 8 million people have been killed by the COVID-19 coronavirus, with more than 4 million confirmed fatalities and more than 180 million people infected since the deadly disease first spread out of Wuhan, China. UNESCO has recommended that the Great Barrier Reef should be placed on a list of World Heritage Sites that are in danger. The world's largest coral reef has suffered 3 major bleaching events since 2015 due to global warming. UNESCO says the reef should be placed on the list at the World Heritage Committee meeting next month. The recommendation also urges Australia to take accelerated action at all possible levels on polluted water from runoff and on climate change. The latter, a rather interesting request, included at the insistence of China, which currently heads UNESCO, especially considering China produces a third of the world's greenhouse gases, and Australia's entire annual greenhouse gas output is lower than China's annual increase in carbon dioxide production. Bruce Pascoe's controversial book Dark Emu looks like it has no feathers after being slammed by some of Australia's leading scientists. Eminent Australian anthropologist Peter Sutton and respected field archaeologist Kieran Walsh, supported by many other academics, have produced what many are calling the definitive critique of Pascoe's Dark Emu. The eminent scientist's new book, Farmers or Hunter-Gatherers, The Dark Emu Debate, meticulously eviscerates Pascoe's book, forensically examining the claims he makes and accusing him of a lack of true scholarship, ignoring Aboriginal opinions and traditional Aboriginal culture. They accuse Pascoe of editing the original colonial observations until they fitted his personal narrative. They say that while Dark Emu purports to be factual, it is in fact littered with unsourced material. It's poorly researched, it distorts and exaggerates many points, it selectively emphasizes evidence to suit the author's opinions, and it ignores large bodies of information that don't support Pascoe's narrative. That's also a view supported by Peter O'Brien's book Bitter Harvest, The Illusion of Aboriginal Agriculture in Bruce Pascoe's Dark Emu. Bitter Harvest was another forensic examination, which showed that Bruce Pascoe omits, distorts and mischaracterizes important information to such an extent that, as purported history, Dark Emu is worthless and promotes a divisive victim-based agenda that pits one Australian against another. The far left-wing Australian Broadcasting Corporation, the ABC, has strongly backed Pascoe's book, with at least 26 ABC journalists and broadcasters promoting Pascoe's claims in Dark Emu. However, in an article for The Conversation, Honorary Senior Australian National University lecturer Christine Judith Nichols says the willingness to accept Pascoe's argument reveals a systematic area of failure in the Australian education system. She points out that while some have described Dark Emu as fabrication, Sutton and Walsh are more measured, methodically showing that in Dark Emu, Pascoe has removed significant passages from publication which contradict his major objectives. This cherry-picking is designed to support Pascoe's contention that Aboriginal people were farmers, undertook sophisticated aquaculture, and lived in houses in towns of 1,000 people. Nichols says that on the basis of long-term research and observation, Sutton and Walsh portray classical Australian Aboriginal people as highly successful hunter-gatherers and fishers. She says in their book they assert that there was and is nothing simple or primitive about hunter-gatherer-fishers' labour practices, which has a complexity that was, and in many cases still is, underpinned by high levels of spiritual and cultural belief. A new study has discovered why people are afraid of the dark, other that is than the fear of what could be lurking there waiting to harm you. A report in the journal PLOS One has found that a section of the brain used for processing emotions could be the reason for your fear of the dark. Scientists at Monash University found the amygdala, a collection of brain cells that plays a role in regulating emotion and fear, could be the key. Researchers scanned the brain activity of 24 people as they were exposed to light and dark and found that light was suppressing activity in the amygdala and allows for greater connection to other sections of the brain that assists in regulating and expressing fear. Or forget COVID-19 and international politics. When it comes to internet clickbait, it's hard to beat stories on alien life and flying saucers. And proof of that is the latest video that's been doing the rounds on the net in India. Tim Mendham from Australian Skeptic says the vision shows what looks like a strange alien-like humanoid creature walking along the side of a road. Or does it?
Okay, a road in India at night and some motorcyclists were driving past and in their headlights vision, which was limited, but they could see this person, this alien figure, long legs, long-armed, very white, walking along the road. And some people looked and ran away or drove away. Others drove away and came back again. And that was filmed. And it was like typical nighttime filming. It's a bit vague, but they got closer. And so the video went viral. Around the world, people said, look, alien, proof of alien walking along the road, looking back over their shoulder occasionally and that sort of thing.
Okay, so I'm looking at this person who's obviously fallen in a box of flour walking along a road in India. Why is this an alien?
And within about minutes, this viral video was debunked by a journalist who had the nerve to actually talk to the witnesses, the people on the bikes, and they said, yeah, we just went back there and had a look, and there was a rather distressed naked lady. But that didn't stop the video from going viral. As we always say, their science travels a lot more quickly than real science does. It looked good. I mean, as far as photos or videos of aliens walking along a road, it's not perfectly clear. It's filmed at night in the headlight of a motorbike.
Why is she covered in white? Is that some sort of a ceremonial thing?
No, naked. No, just a very pale person.
Oh.
And in a bright light of a headlight, they look white. There might have been it was obviously someone who was disturbed, okay?
Oh.
Now, whether they'd escaped from some place where they'd been kept, they were just a very white person. They were naked.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.